Minutes late.
Okay.
Yes. Good evening, everyone. So, welcome for the Java learning. So, today's is a continuation for the multi-threading. So, today is the last topic for the multi-threading. So, we have seen like thread creation ways, and difference between each, and we have seen couple of methods, setting the names and setting the priorities, and also we have seen the sleep and join methods. So, what is the usage and all. Then also we have seen for this termination. So how it can be terminated with thread. Then we have discussed about the synchronization as well. So how it can be achieved, what are the ways of synchronized block and synchronized method, and which one to choose in the real time according to the requirements. And I think, yeah, majorly we have covered, these are all the topics in multi-threading. Okay, then we have started the discussion for the inter-thread communication. So inter-thread communication, let's see why it is required. Inter-thread communication means there should be two threads, both should be communication. So that communication should not be cause any problem. Okay, let's see if there is no proper communication, what happens. Okay, let's see, there is a shared class is there, and I'm having two synchronized functions. One is method one and method two. So what I'm doing inside that, so inside the method one, I'm calling method two. Inside the method two, I'm calling method one with the two different objects. Okay, then let's say threads T1 and T2. So what I'm doing in the T1 thread, I'm calling with the S1 method, the method one I'm calling, and I'm passing argument as a S2 object. Okay. So in S2 thread, I mean T2 thread 2, what it is doing, it is calling method 2 of S2 by passing argument as S1. Okay. It is vice versa. Like I'm calling from
Chetana,
Chandrasekhar, is everything fine?
sometimes there is no network, so that is the reason.
Oh, okay.
Uh,
Okay. So is that fine to continue with you? Now it is fine, right?
Yes, fine, fine. It's fine.
Okay, fine. So with each method, like S1 comes to method one function. Okay, it will come here. Then it will call the method two, but with S2 object I am passing actually. So with S1 it will come here. Here S2 will calling S method 2 by passing argument as S1. So similarly, S2 will come to method 2 and it is bringing the S1 as argument, and here S1 dot method 1. So mutually actually. So what happens is for completing method 1 for T1 completion, it is depending upon method 2 also needs to be executed with S2 thread, S2 object. Similarly, for thread T2, what is required is it has to complete method to execution. So for completing the method to execution, it has to call the method one execution by using the S1 object. Okay. So it means mutually like if S1 wants to complete, it has to S2 task it has to call. Similarly, for completing S2, it has to call the S1 task. So it is mutually. So like this way we have done. Let's execute now. See if you see here, so it is calling method 2. Thread 1 is calling method 1. So both are blocked. So it is not, it will never get terminate because both are locked actually. Why? Because these are the synchronized. Let's see the flow is. Okay. So thread T1 started. What T1 is having the logic? It is starting S1 dot method 1 of S2. So with this object, it will come and execute method 1. Method 1, what it is? Synchronized. So synchronized means it should have the lock of that particular object. So for the S1, already it acquires the lock and it enters. So if you see at this point, thread 0 entered here with S1 lock. Okay. And what happens here? Thread T2 is entered with method 2. Okay. Method 2 is also synchronized. So what happens here? Thread 1 entered here with S2 object lock. Okay. So by this time, S1 lock is engaged here, means acquired by thread 0. S2 lock is acquired by thread 1. Okay. So both the threads are acquired the lock of each other object and they have entered with the execution. So when it come here, what it is calling here? So it has to call method 2 with S2. Okay. It has to call method 1 with S1. So to call with method 1, which is a synchronized, so that needs S1 object lock. So similarly for this, it needs S1 object lock, but that is already held by other thread. So both are locked actually. So until it releases the lock, it cannot complete its execution. Until it releases its lock, it will not complete its execution. So that is called like deadlock. So if you see here, still the execution is going on. So it's not terminated. So both are waiting for each other. If you see, thread 0 is calling method 2. Thread 1 is calling method 1. So both are like interdependent on each other and both are not able to continue further. So this situation is called deadlock in Java. Okay. This is the deadlock. Second deadlock is the producer and consumer. Okay. Producer consumer means why inter-thread communication is required. See here, if you see inter-thread means two threads are there, they are not communicating properly. So they both are trying on their own, on their independent life cycle. That's why they got stuck here. So instead, that's why the inter-thread communication has to be done. So another example is, let's take producer and consumer. Okay. Producer who is the one who is producing always, and consumer is the one who is consuming always. So in case of the producer and consumer, the proper communication should be there. Why means if producer produced, then only consumer can consume. Correct, right? If somebody is selling, so there should be somebody is purchasing. Otherwise, he is keep on making the things and keep on storing. It will not work actually. So you should prepare something. It should look like somebody should purchase it. So based on that, like he can prepare for other one. So it's a similar actually. So there should be proper communication. So once producer is produced, he should inform to consumer. Hey, consumer, I have produced something. You can come and consume. So similarly, once consumer is consumed, he should inform producer. Hey, you have already, consumed. You don't have anything for produce, so you produce now. So like this communication is required. That is called like inter-thread communication. So even here also, thread 1 is there, thread 2 is there. So they both are not talking each other. That's why they ended up like this. So instead that they could have communicated properly, then this situation could not occur. Okay, so that's where the deadlock is, and that is importance of inter-thread communication. So inter-thread communication will be achieved in multi-threading by using three of the functions. Okay, so one is wait method, another is notify method, another is notify all. So by using these three functions, the inter-thread communication will be achieved in Java. Let's see the example is. So wait function. So what wait function will do is it will keep some condition. Okay. So it will check whether I have to wait or I have to continue. Okay. In case of the producer, what he will do is he produced one item. Okay. He is waiting for producing the other one. So what he do? He will notify. Wait is nothing but it passes the execution. Passes the execution. So it waits actually. So it will be waiting, okay, and notify one wake up the waiting thread. Okay. So notify all means it will wake up all the waiting threads. So like this actually. So whatever I mentioned, right? The producer. So what he will do is he will come and first produce, then he will notify. So till the time consumer will be coming, he will check like, okay, is there something for me to consume? So there is nothing to consume because producer has not yet produced. So he will be waiting. Okay. So once producer is produced, then he will call notify. Means he will notify the consumer. Hey guy, there is something is available. Okay. Then from wait, he will come to the normal state and he will consume it. Once he will consume, again, he will notify the producer. It's a kind of first producer come because in the multi-threading, what happens is producer and consumer both started their execution. So first producer and consumer will come and check. Okay, is there something for me to produce or not? I mean, consume or not? If there is nothing to consume, he will wait. Okay, then producer comes. He will check whether it is already consumed or not. Okay, if there is everything is consumed and first time there is nothing produced, right? So directly he will produce. He will produce and he will notify the consumer. So the consumer from the waiting state he will come active state and he will go and consume. So till the time producer is waiting. What he will do? He will notify the consumer and he will wait till consumer consumes it. Okay. Then once consumer consume, he will notify the producer, hey, I'm done. I have consumed. So you can produce now. So then consumer will be waiting state and producer will come as active. So he will produce one more item. So once he produced one more item, then he will notify the consumer. So then consumer will come active. He will consume till the time producer will be waiting. So it's a kind of like producing one item. He will wait till that to be consumed. So once it is consumed, again he will produce one more item. So once he produced, he will notify the consumer. So consumer, what he will do? He will consume and he will wait till another item is produced. It's this is the way the communication will be happening. Okay. For making that communication, these are all the functions will be used in Java. Wait and notify. Wait is the one which will go for waiting state. So producer comes, he checks, oh, there is already the produced one is not consumed. So I will go for wait. Okay. The consumer is the one who consumes, then he will notify each other. Okay. So wait is the one, it will pass that execution, it will go for the waiting state. Notify is the one which wake up the waiting thread. Okay, for the continuation of their execution. So this is how the inter-thread communication is implemented in Java. Let's see programmatically. Yes, same program. Let me comment this. Control A. Okay. Yes. So whatever the deadlock we have seen, right? So both got locked. So let's see how that is fixed with the inter-thread communication. See, the execution is not completed yet. So I'm terminating forcefully. Okay. I've terminated that one. So what happens here? See, if you see here, so method one. So within that method one, the thread whichever comes, it will wait. Okay. Then it will continue with the execution. Okay. In method two, what happens is directly it will continue with execution. Once it is done, it will notify the thread. Means what we are doing is we are making thread one to wait till the completion of thread 2. Then what thread 2 will do? It will come here, it will complete all its execution, then it will notify thread 1. Hey guys, like I'm done with my execution, you can continue with your stuff. So then the thread 1 continues with its execution. So that's where, so they mutually they have come for some agreement to make things should go proper. Okay, let us run this program. See here, first thread 0 started. Okay, what it is doing? It went to the waiting state. Okay, so then another thread started its execution. They have completed that one, and it has notified the thread 0. Now, after notifying, the thread 0 came active and it's continued with its execution and it is completed. That's why the program is terminated properly. So this way, they have done the inter-thread communication. Okay. So here, if you see here, we have used this wait function and we have used notify. So by using this wait notify, the inter-thread communication has been happened. So within this, the difference we should see here. So wait, what it is doing, it is also going for passing the execution. And we have discussed that sleep is also passing the execution. So then what is the difference between these two? Okay. So in case of the sleep, that is there at the thread level. Okay. The current thread, whatever is coming, I'm calling thread.sleep. See here, thread.sleep is there. So the current thread, whichever enters here, it will pass its execution for 5 seconds and it will continue. But in case of the wait, whichever the thread is executing here, it will wait. So means it will go, it will pass its execution and it will release the object lock. So the only difference here is in the wait method, the object lock will get released. Okay. So that's where like in the synchronization, so even though here it is a passing its execution, but method 2 cannot complete calling method 1 without the object lock. So that's why the wait has implemented in such way that whichever the thread is waiting, it will release that object lock. Okay. So that object lock is available. So that's where from thread 2, what it is calling. Yeah, it is calling s dot method 2. Okay, within the same thing. So I have created one object, method one and method two I'm calling. Okay. So only one object is there, means one lock is there. Two threads are there. So first T thread 0, which will come here, it will wait. So it means it will release the lock of the object S. So only one object is there, right? So that's where the thread 2 will acquire that lock because that is available actually. Because thread 1 got the access, but it is released. So that's why thread 2 got that lock and it continued with its execution. And whichever goes for the wait, it will release the lock and it will be keep waiting until somebody notifies. Okay. So second thread, what it has done, whatever the lock released by the first thread, that was acquired by the second thread. It entered into the synchronized block. It has waited for 5 seconds. Then once it is done with this, then it notify the thread one, first thread. Hey guy, like I'm done with my execution. It will notify and it will go back for the waiting state. See, wakes up one thread randomly, which is waiting for the lock of this object. So it will wake up this thread one and which will provide the lock for that. So the same thing. This is also released as the lock. This is also released as the lock. Okay. That's where the inter-thread communication happening between the shared resources in case of the synchronized keyword. Is that clear? So what is the deadlock and why inter-thread communication is required and how that is implemented in Java? Just like, is that clear for everyone? Okay. If anybody is having doubt, like I can ask because it's very important topic in multi-threading. So deadlock is also like no, most of the interviews will be asking, and also like they will be asking for how inter-thread communication is has been implemented in Java. So that is also like damn sure question in multi-threading. Okay. So it's a similar like let's explain this producer consumer thing here, whatever I explained, right? The same concept actually. So what is this producer? Producer, what it is doing? If the size, so they have defined some size. If the size is full, what it will do? It will wait. Means it will wait for someone to consume. Okay. So if it is size is not full, then it will add and it will notify the consumer. So similarly, in the consumer, what it is doing in the consume function. So first it will check list means there's nothing to consume for me. So what I do, I will wait. Okay, that's where like it's wait. So once it is available, then it will go on consume. So once it is consumed, it will notify the producer thread. So wake up the producer thread. Okay. Similarly, like just by using the wait notify all. So by using these functions, we can achieve like inter-thread communication in Java. Okay. So with this, like we completed this multi-threading in Java. So as a continuation for this multi-threading, we are having like no concurrency. Okay. Within concurrency, I will be covering only the thread pooling, means executor service. So there is executor framework in Java. So I will explain that. So with that, like we will wind up thread concepts and concurrent everything. Yeah. So till now, what I've seen is we are creating one thread and we are taking care of the we are ourselves starting the thread, ourselves creating the thread, ourselves like no ending the thread. So once it is ended, means terminated, there is no provision to restart. So there is a bottleneck. Like, so if I have 100 tasks to be performed, I need to create 100 threads. So a lot of time is getting involved in it. So that's why the Java, like they have introduced executors framework. So executors framework is nothing but it's a kind of like thread pooling. Thread pooling means so there is a pool of threads which are getting created and maintained by JVM. Okay, means readily available threads. So in your program, what you can do is directly without creating the thread, you can use the thread. Okay, the advantage is, let's take here is the example like how we can create like, see what I'm doing, executors dot new fixed thread pool of 10. What it indicates is it will create 10 threads. Okay, it will create 10 threads and JVM will be maintaining all those things. So those will not get terminate actually. So what happens is if any task is coming, so one thread will come, it will execute. If parallelly they can accommodate 10 tasks, means 10 threads can execute at a time 10 tasks. So once if I have more than 10 tasks, what happens is whichever the thread completes its execution, it will come and pick another task. So it's kind of reusing. So there will be set of 10 threads are there. They'll be keep accepting the task and finishing the task. So they will not get terminate like regular thread way. Like, so if you see here, I did not create like thread. I did not start the thread. So everything is managed by JVM itself. So that is a concept of thread pool. So pool of threads are already available. So the benefit for this is there is a time required for code and time required, right? For creating, for instantiating, and for starting the threads. So these are all the things are not required. Okay, one time. So directly you can define how many threads you want. So in the previous thing, if I want to start 10 threads, how I have done, see here, see for 4 threads, what I've done, I have created myself and then I have started by myself. So everything we need to manage. But when it comes for this one, even though I have declared 10 threads, so these 10 threads will get created at a single time, and those are ready for accepting the task. So I did not create explicitly, or I did not started those threads explicitly. So that is the advantage. That is a concept called like thread pool. Okay, that thread pool is implemented by using the executor framework in Java. Let's see. So within that executor framework, we are having couple of services. One is executor service. Okay, means so I want to create some fixed number of thread pool. In such cases, we will use this API. Executors is a utility class. Let me show you that. See Oracle documentation. This is the API. This is part of Architecture. Okay. So under util package, java.util package. So it is having these many functions actually. So if I want to create the cache thread pool, I can create the cache thread pool. And if I want to create like fixed thread pool, means create a thread pool that resumes a fixed number of threads operating of a shared unbound queue. So how much number you will give? that many threads will get created in a single shot. So, and also we have one more thing is scheduled thread pool. So I will explain you in 2 days only, like post the fixed thread pool. Okay. So and also like if we have like only single thread, so in such case like see single thread executor. So I can create one single thread. There is a pool with single thread. So pool with multiple threads is this one. Pool with single thread is this one. So according to our requirements, we can call all these things. Okay. Even in the scheduler also, we are having like single thread. Also, we are having thread pool for the schedulers. So we can define the size of it. So it is having like many other things actually. Okay. So all these things like this is the utility class, which is having the implementation for creating the pool and managing it. That's why what we do in our programs is directly we will call the existing implementation. See, we did not implement anything. So it's already available in Java. I just defined how much number. So whenever this line got executed by the JVM, what JVM will do is it will create these many one thread pool with 10 threads. Okay. So at this, after this point, there is a one thread pool is ready with the 10 threads. So 10 threads got created and they are waiting for the task to execute. So how do you submit the task is, this is the one thing. So we can call like execute or submit function. So by using that, we can submit one task. So this task remains the same. Either you define as a anonymous inner class, or else you can class A implements runnable and you provide the implementation for public void run. So that remains the same. So you can use any of that method. Okay. Either this is the another way of thread creation. So I don't want to create a class for this. So that's why I'm using anonymous inner class. Anonymous inner class is nothing but nameless class. Okay. If you see here, no reference for class, no reference for object also. So this is also, who can create some classes actually in Java. Those classes are called anonymous inner classes. So I have used this one. And so this way I'm executing. So I'm telling this executor service, you execute this particular task. So it will execute this particular task. And what I'm doing after that, shutdown. So because I mentioned that if you're starting individually your threads and at the end of the execution of that particular thread, the thread will get terminate. Okay. But that will not happen here. So because I said, right, those are reusable. So the only option is enter the pool you can shut down. So what I'm telling, executive service dot shutdown. So it will shut down the complete pool itself. So all the threads will go for termination here. So similarly, here 10 threads I had given. Here I have taken the single thread. So for the single thread, I have given like one task for the execute. So that task is this one new runnable task. And I'm post execution of that. I'm telling you also shut down. Okay. Let me execute. I think both I can execute, no issues. See here, first thread in this thread pool, I have submitted one task which will be printing the executor service. So even in the second thread, second pool also, where only one thread is there, I had given the task to print executed service. So if I see here, see both are printed a execution service means the task got executed in both the cases. That's why we can see the whatever is the task it is printing rate executed service and program got terminated. So I made sure end of my program I'm shutting down the pool. Okay. This is another concept called like thread pool. So which is implemented by using the executors framework. So within the executor, we can see executor service. So this is one class. So which is having like no the submit and execute all these kind of functions. So let me show you that also. See here, executor service. Let me go here. See, these are all the functions actually. Invoke all, invoke any, is shutdown, is terminated, and shutdown. So this is the shutdown we have used. Shutdown now and submit. So submit is the function. You can submit any task. So here, two kind of submits are there. So if you see here, it's a runnable and it's a callable. I will explain the difference between these two, runnable and callable. Okay, but you just remember as of now. So for submitting the task, I'm using submit function. Also, so implementation is available in see here execute. So because it's a pool object, so it is having either you can go for uh, submit function or you can go for the execute function. So and also like before executing any task, if you want to perform some other thing, so that also we can instruct before executing this task, you please do this task. So that is also available here actually. So here it will give get active count. So out of this pool like 10 we have seen, right? How many threads are active? Okay, active count means active. So others are already engaging. Okay, and so that is the one. So core pool size and what is the completed task count. So how many tasks it has been completed and largest pool size, maximum pool size, and what is the pool size. So these are all the things functions available to get the data function. So how many tasks are there? Shutdown is terminated and terminating purge. So these are all the other functions available. Shutdown. Shutdown we have seen. So there is a difference between shutdown and shutdown now. Shutdown means let's take I've created 10 threads. They're performing out of those 10 threads, 8 threads already completed the execution, but 2 threads are still completing the task. Okay. In that time, if I call the execute, what happens is if I call the shutdown will not happen immediately. It will wait all the tasks completed. Okay, whatever is picked. So those all should be complete means all threads should complete their execution. Then only it will shut down the pool. So means there is a delay. You cannot guarantee that like so immediately if you call the shutdown, there is no guarantee that like the pool will get shut down because if there are any threads already they have picked one task and they are in between the execution, so they will not shut down immediately. So there is a that's why they are given one more shut down now. You leave everything and you shut down now. Whatever the state you are, you die there. It's a kind of instruction. So that is called like shutdown now. And it will return what and all the tasks like no, the pending state. Okay. So post shutdown, we can check like whether it is terminated or not. So all these kind of functions are available. Okay. This is the executor framework in Java. Now, if you see here, we have seen one more thing is callable. Okay. Let's see. Callable is also one of the tasks. See, runnable is also task, right? So, but only the difference is if you see in case of the runnable, let me open that. You can understand in better way. Runnable interface in Java specification. let's go here. See, runnable is nothing but, as I mentioned, it's an interface. Okay. Whenever you are implementing an interface, whatever the abstract methods are available, you need to override. So if you see, there is a one function, so which is abstract function. So run method. So that's why wherever we are using implementing this runnable, right, we are providing the implementation for the run method. And if you see, the type of the method is void. Okay, void means it will not return anything. Okay, let me explain that. Okay, void method one, system.out.println method one. It's done. Now int method two, system.out.println method two. See, there is an error here for me. Let's see what is that error. See, this method must return a result of type integer. So within any method signature, there is a return type will be there. So that represents, okay, this function returns this type. So what I'm telling here is, this is the function method 2, which returns output as integer value. So, but I did not return any integer here. So if I say return 1, see, error has been gone. Means there is some result will be returning by this function. In such cases, we will define the return type for this. And if we have some functions, it will not return anything, but it will perform the all my required actions. So in such cases, we will define that as a void. Okay, that is a void. And let's go for it. Here I have seen the integer. Let me go for string type. Method 3. Even here also same thing, because there is some return type is there, the string you have defined, but it is not returning anything. So what happens? Return something ABCD. If I return some string, it is satisfied. So that is the significance of the return type here. So when we come for the runnable, the run method ideally is, it will not return anything. Okay, it's just the void. So whatever the task you create by implementing the runnable interface, the task will not return anything. Okay, it will not give any response, but it will execute whatever the things are required for me. But at the end of the thread, it will not return anything. So that is the one. So that's why we are having one more interface in Java. So that is callable. Okay, let's see what it is. See, both defines a task. Even runnable also defines a task. Callable also defines a task. But there is a slight difference in providing the task actually. This is also interface, callable. If you see here, there is a call function is there. Okay. In case of the runnable, I was overriding the run function. But if I'm going for the callable interface for creating the task, I need to provide the implementation for the call function. So, but it is having some return type. Okay, it is having some return type, and at the same time, it can throw the exception. But when it comes for the, sorry, when it comes for the run method, it is not even throw the exception, and it will not return anything. So these are the major difference between runnable and callable interface in Java. Okay, let's see now the programmatically with the call. So we have seen this executor service. Here, everything is runnable. So the task is created by implementing the runnable interface. That's why inside your run method, so you don't see anything is returning. Okay. And at the same time, it is not even throwing any exception here. So let's see one example with the callable. Yes. Sorry. See here, it's also same thing like, so I created like single thread executor. So if I go here, here also same thing, new single thread executor means I'm creating a pool with single thread.
No,
Yes,
your screen is not visible now.
now let me, yeah, I think sharing got stopped. Yes, can you see now?
No, now it's okay.
Okay, so here also I have created a pool with single thread. Okay, here also whatever I'm doing, the same thing with callable I'm trying to project you guys. See, it's the same thing. So the creation of the pooling is same. There is no change. And submitting the task is also same. Either submit or execute, you can use anything. So, but what I'm providing here, callable I'm providing. New callable. So I was doing before new runnable. So if it is a callable, I need to override the call function. Okay, call function and the syntax throws exception and it is having some return type. So we can define like according to the action, if integer or string anything. So here I define a string. So what it is returning? Task 1. Similarly, I have created one more callable task, task 2, another callable task 3. Okay. So now what I've used, invoke all. So that's where like even execute, if you use single each task level you can give. So instead that what I have done is I have added all tasks to one set. Okay, the set and all we will see in collection framework. Okay, next topic. So it means list of the queue or list or anything you can take. So it's nothing but an array. Okay, callable array I have defined. So invoke all I can pass as that array. Okay, this is a one way. If not, so what we will do, array how we will retrieve. So we will use a for loop for int I is equal to 0, I less than array dot length I plus plus. So in such case, executor service dot execute of each task level we can submit. So even that is also can be fine. So any of the way we can choose. But if you have like multiple tasks and if you want to execute all such tasks, you are having the function called invoke all. Okay, that's where like I have shown you here. Okay, let me minimize. Yeah, this is the one. GHI, right? Executor services. Yeah, either invoke all. So if you have array of the task, you can submit everything in a single, or else invoke any if you want any one to be picked. Okay. Otherwise, if you are willing to submit by your own each task by traversing, so array we can traverse, right? We can get everything from array one by one, and we can use execute function itself or submit function itself, which is having the single level. It will take as the argument. So any of the method we can choose. So I have chosen invoke all just to make the difference for you guys. So the all available functions like no to get exposure. So I use differently here. Okay. And also what it is doing is it is returning the future object. So because the return type is there, right, for each callable. So once the thread, so here I have just submitted the task, but execution is not completed. So that's where the future object is there. Okay. This is the feature is the one more in Java. Let me open that feature in Java. So this is the one more interface. Okay. Feature interface, because callable returns some output, because the callable returns some output because the call method is having some return type. So I should have something which will capture that once the thread execution completed, returns back for me. So for that, they have implemented this feature interface. Okay. So what this feature will do is, so it will check like once the thread is completed its execution, by using the feature.get, we can get whatever the outcome of this, we can get it like this. So then I'm shutting down all my executor service. Let me execute this function. What will be the output? See here, task 1, task 2, task 3. So these are all the outcome of my 3 threads, 3 tasks. So 3 tasks are there. So those tasks are written in something. Okay, here the sample set we have taken task 1, task 2, task 3. But in case, let's take for the different tasks are there. That's where like, see, India wise population I need to calculate. So what I need, how I can do that actually, I need to get all state level population first. So how many states are there? From each state, I should get the population. Then I will summarize all those population. Then I can get the country level population. So let's take the callable task I have defined for each state. Okay. So there should be outcome, means there should be response. Okay. Let's take for the Andhra Pradesh, I have created one callable task. So that should return here the population of Andhra Pradesh. So like that, I can create 28 tasks or 29 tasks. How many states are there? That many I will do. All the tasks will return something like this. So by using the feature dedicate, I will do, and I will add all those things that will give me the country population. So this is a one kind of like no real-time example, like practical example. Okay. Similarly, like you might be having like no some task will be doing something, and you need to get the response of all the tasks, and you need to summarize, or you need to do some calculations, or you need to do some manipulations and all. In such cases also, you can go for this kind of callable instead the runnable. Clear? So once it is done, there is a one more within the executor itself, which is scheduled executor. So we have seen till now executor service, okay, which will be immediately comes to the action. So once you could submit, it will execute it. Okay, but there can be the requirement that I don't want to do this now. It needs to be executed in some particular time. So generally, like no, we used to get this one at particular interval, like no, 12 o'clock, like birthday should be done. Okay, or else like 6 o'clock, like some activity should be done. So all these kind of requirements can be taken as example for this. So for that implementation, scheduled executor service. Okay, the creation is the same. Executors dot new scheduled thread pool. Initially new fixed thread pool. Here new scheduled thread pool. Okay, that's it. And I will give some task. The task creation also same. So there is no change in the task creation. That only one thing is there we were given the execute. Here we will give the schedule. What I'm telling schedule, you have to execute the task to after 5 seconds. Okay, for every 1 second. Okay, after 5 seconds, for every second, like no, you need to execute this. So that's where like means after 1 second, so second delay should be there. So let's see execution now. See 1 3 completed, but 2 I said like no after 5 seconds. See 2 came now. Run this task after 5 seconds. So that is instruction telling that like schedule. So if you want like even more time also you can give like one you can give and you can represent the hours. So it will execute after 1 hour. Even in the minutes also you can do. So like this you can define okay when it needs to be executed. So what is the delay you want? Okay, let's see the syntax of it. See the schedule and runnable. What is the task it has to perform and what is the delay? So means after how long this needs to be executed. So this is a one example of the scheduler. So within the scheduler, let's see for the repeated things. So I said right. So periodically, if you want to run something, so in such cases also, we can use this one. See, schedule at fixed rate. Schedule at fixed rate means at particular interval, repeatedly, this particular task needs to be executed. In such cases, we can use this one. So what I'm telling here, after 5 seconds onwards, you repeat for every 1 second, you execute the same thing. You execute the task one. So what the task one is, it just increasing the counter and printing the counter. Okay. So for that, just I have taken the loop count, like when it's to be terminated. So what I'm telling is, if the count is 5, you just cancel the scheduler and shut down exit because otherwise it will execute for infinitely. So just to instruct. So let's see every second like it is printing like this. And now let's see the task, see running task one, count one. So every 1 second that the execution has taken. So after 5, I'm terminating. So like this. So this timing and all you can define hours, minutes, anything you can do. See here. So what is the runnable command and what is the initial delay means of first time when I'm starting execution, what is the delay I need to take? Then long period. So how much periodically? What is the periodic interval? Then what is the time interval? Means whether it's a seconds or minutes or hours, all these things we can define. So this is also one more thing. So we have seen this normal like immediately you want like some pool needs to be created and you are having the ready-made task are available. So once you submit, that will execute immediately. So in such cases, you will go for executed service. Okay. Instead, you want to schedule some things. Okay. If you see real-time example as maintenance task. Okay. All maintenance tasks for any service that will do at particular interval. So this is like schedulers for that. Like this, also like no, there are like cleanup activities that is also can be done. By schedule, we can schedule like no, okay, every day 12 o'clock, you go and do the cleanup activity, or you go and you go and perform some particular task. So you can instruct for such kind of things. Okay, maintenance activities. Maintenance activities means cleaning up anything or freeing the memory, all these kind of things. We can do it. Okay. In case of the log files we are having, so you need to repeat at 12 o'clock with the date, I mean current day in the file name. And for the next day, you create with a different file name. So all these kind of things like no anything. We can take example cron job is there, right? I mean anybody is having Linux environment background. So there's a concept called cron job. Cron job means like at fixed interval every time it will get re-executing. So similar things you can implement by using the schedulers. Okay. So if you want
Guru bro. Hello, bro.
బ్రో సురేష్ బ్రో ఏదో కట్ అయిపోయినాడు అన్న.
గురు బ్రో నీ వాయిస్ వినిపించట్లేదు.
And Executor framework. Okay. Tomorrow onwards, like we'll start with collection framework.
Okay, bro.
Any doubts in
Okay, bro.
today's topic? Yeah.
Can I stop recording?
Thank you. Yes.